So let me remind you or repeat what I just said before. Horizontal period tells you the total number of electron shell. The vertical column tells you the number of electrons in the outermost shell. So remember these two definitions, it will help you a lot. So this is the answer of drawing the calcium atom. So it has 4 electron shell. So first one, it has 2 electron, 8 electron, 8. The third one has 8 electron, and then the fourth shell, it has 2 electron. Now let's draw the structure of calcium ion 2+. What does 2+ means? It means that calcium atom loses 2 electrons. The 2 electron the calcium loses is at the outermost shell. That means the 4th electron shell. So this is the tips. Calcium loses the 2 electron on the 4th electron shell. So then draw it. When you draw it, it looks something like this. You put calcium, you set calcium 2+ here in the center, and then you draw the electron shell, the first electron shell, the second electron shell, third electron shell. Well, again, I'll stop here. You will finish the rest. So it looks like this. So after you draw the electron shell, you have to put a blanket here, a bracket here, and then you put 2+. Of course, you can do it the way I do. I put the calcium 2+ in the center of the nucleus. That's also acceptable. As you can see that the electron, they are paired up 2 by 2. Okay. Now another exercise. Try to draw a sulfur atom. It's atomic number 16. That means it has 16 protons and 16 electrons. So 16 electrons, how are you going to arrange them? Well, I'll let you do it by yourself this time. And this is the answer. So it has 3 electron shell, 2XX. This is not very conspicuous. Let me highlight so they can see it clear. 2XX. So it has 3 electron shell. The outermost electron shell, you have 6 electrons. What about sulfide ion? We call it sulfide ion or sulfur ion. Sulfide ion. Sulfur ion. So it is 2-, meaning that the sulfur atom gains 2 electrons to become sulfide ion. So as I said, it gains 2 electrons, so it becomes -2. And then after it gains 2 electrons, then the outermost shell will be completely filled. When the electron shell is filled, then the ion become happy because they are stable. So what if you put calcium ion and sulfide ion together? What will happen? Calcium is 2+ ion, Sulfur is 2 minus. What will happen? It will become calcium sulfide. Calcium sulfide. So what happens is that the calcium atom will give the 2 extra electrons to sulfur atom. The sulfur has 6. They want to get 2 more electrons. So this is what I like to say, that when someone want to give and then the other person want to receive, then they form a bond. Opposite charge attract each other. Well, an analogy is like getting married, basically. So calcium, it has a 2-carat diamond ring, and sulfur, it really want a 2-carat diamond ring. So calcium, like a guy, proposed to the sulfur. So calcium give the 2-carat diamond ring to sulfur. Sulfur get the 2-carat diamond ring, and sulfur become very happy. So and then they form a bond. So it becomes one becomes calcium 2 plus, one becomes the sulfide 2 minus. Because opposite charge attract, the attraction force between the opposite charge, we call it ionic bond. Okay, I hope you like my analogy about forming an ionic bond is like getting married. It's a complete transfer of an electron. So when calcium proposes to sulfur, the diamond ring is completely given to the woman, the sulfur. Element and compound. Let's take a look at the differences between element and compounds. So the first thing we talk about is molecules. Molecules, when we have 2 or more atoms bond together, we call it molecules. For example, oxygens. Well, I would add to this 2 or more same atoms or same element. Same element. When you have 2 or more atoms of the same element bond together, we call that molecules. But for compounds, it is formed by different elements bond together. An example would be water. In other words, in our daily life, we like to say water molecules. Water molecule, it is, well, I would say scientifically incorrect in terms of the definition. Theoretically, we should say water compounds. Water compounds. But since we get used to call it water molecules, then, well, I guess it is okay to accept it. But technically, we should call it water compounds and oxygen molecules. So when chemical reaction occurs, energy may be released or absorbed. What does it mean, chemical reaction? Meaning that forming and destroying bonds. Forming and destroying bonds, chemical bonds. When we form chemical bonds, then energy absorbed. When we break chemical bond, energy released. I want you to memorize this. This is very important. When we form chemical bond, energy absorbed. When we break chemical bond, energy release. So it is very important for you to memorize this. So bond forming, absorb energy, bond breaking bond, release energy. You remember this? Make sure you remember it is very useful. So ion, they are charged particles, charged atom. When atom lose an electron, or when atom gain an electron, they will become ion. So you can have positive ion or negative ion. And electrons are transferred from one another. This is my wedding or marriage analogy. Remember transferring the diamond ring. We will focus on two types of chemical bond, ionic bond and covalent bond. Ionic bond is a complete transfer from electron, is a complete transfer from one atom to another. So again, attraction between the oppositely charged ion, we call it ionic bond. It's like opposite attract. It is kind of similar to the real life human dating or marriage example. If you look at your parents, or if you look at your partner, you can see that you are very different from your partner, or your parents are very different from each other. So opposite attract. So this is the classic example of ionic bond. Sodium has one diamond ring, wants to give. Chloride wants to receive the diamond ring. So sodium gave the diamond ring to chloride. Then sodium become positively charged. Chloride become negatively charged. And the complete transfer of the diamond ring, we call this ionic bond. They are oppositely charged, attract each other. So this is the ionic bond. Ionic bond. Covalent bond. It's like they share electron. So the hydrogen has one electron, and then the other hydrogen has another electron. So they share the only electron with each other, so that they appear to have two electrons. So each hydrogen atom appear to have two electrons for each other because they're sharing. So this is covalent bond. Analogy of covalent bond is like cohabitation. So when a man and a woman, they live together, they share everything with each other, but they are not. It's not a complete transfer. It's just sharing. But even it is the case, some of the cohabitation couple, let's say Kurt Russell and Goldie Hawn, well, most of you may not know who they are. They are too old. In my generation, they are famous celebrity couple. They are famous for having a very strong bond, even though they are not married. They have been living with each other for so many years, and they have never been married because they don't believe in marriage. But their bond is very strong, so we call it covalent bond. In hydrogen, in the example of hydrogen, we call this a single single covalent bond, a single bond, because each atom share only one electron. For oxygen, we call it a double bond. Why? A double bond because each oxygen atom share 2 electrons. Single, they only share 1 electron to each other. So another example is